and the spark of physics, electric charges and fields. It was a dry afternoon in Tokyo, and the air in Nobita's room was heavy with the stress of the upcoming physics midterm. As Nobita pulled off his thick wool sweater to sit down, a loud crackle and a bright spark made him yelp. "Doraemon, my sweater just bit me," he cried. Doraemon looked up from his comic book. "It didn't bite you, Nobita. That was just a discharge of static electricity. You've been accumulating electric charges from the friction between your shirt and that sweater." "Friction?" Nobita asked. Doraemon reached into his 4D pocket. "Exactly. When you rub two insulators together, electrons, the tiny, negatively charged parts of atoms, get transferred. To see it, we need the everything magnifying mirror." Doraemon pulled out a large, ornate hand mirror. As he pointed it at the sweater, the surface showed millions of tiny blue spheres hopping from the shirt to the wool. "This is electrification by rubbing," Doraemon explained. "No new charge is created. It's just moving." Jian, who had been trying to study in the corner, sat up and frowned. "Wait. If I rub a balloon on my hair, I'm creating electricity, right?" "I'm the creator." Doraemon shook his head. "Common misconception, Jian. You can't create or destroy charge. That's the law of conservation of charge. Also, remember the law of additivity. The total charge is just the algebraic sum. Like plus 5c plus minus 3c equals plus 2c. You're just a transferee." Jian looked annoyed, but the mirror showed the electrons simply changing homes. Shizuka, who was diligently taking notes, looked up. "And don't forget quantization, Nobita. Charge doesn't come in just any amount. It comes in packets. We use the formula Q equals N, where N is an integer and E is the basic unit of charge, 1.6 times 10 carat minus 19c. You can have 100 electrons or 101, but never 100.5. Nobita groaned at his notebook. Shizuka smiled. "In exams, we usually deal with microcoulombs, μc, because 1 full coulomb is a massive amount of charge." "Now, let's look at the force between charges," Shizuka continued, drawing a diagram. "This is Coulomb's law. F equals Frank 1, 4 pi epsilon, underscore 0, 4aq, underscore 1, q, underscore 2, r squared. The constant frac 1, 4 pi epsilon underscore 0, is roughly 9 times 10 to the power of 9 nm squared / c squared in a vacuum. It's an inverse square law, just like gravity, but much stronger." Nobita stared at the fractions. "So the further they are, the weaker the push?" Shizuka nodded. "Exactly. The force decreases with the square of the distance r." Tsuneo leaned over, checking his high-tech calculator. "Hey, Nobita, here's an exam shortcut. The sign of the charge only tells you if the force is attractive or repulsive. When solving numericals, just use the magnitudes q underscore 1 and q underscore 2 to find the strength. Then decide the direction based on like repels, unlike attracts. And if there are multiple charges, use the superposition principle. Just add all the force vectors together. Use your geometry, not just your addition." Doraemon pressed a button on a new gadget, and suddenly, the room was filled with glowing blue lines. "This is the electric field, E," Doraemon announced. "Think of it as the influence a charge has on the space around it. E equals Fry FQ, or for a point charge, E equals Fry 1, 4 pi epsilon underscore 0. Fra QR squared." Tsuneo reached out to touch a glowing line. "So, these lines show where a positive test charge would be pushed?" Doraemon nodded. "Yes, they start at positive charges and end at negative ones." Jian grabbed a marker and tried to draw on the wall. "If I have two charges, I can just make the lines cross each other to save space, right?" Doraemon jumped in alarm. "No, that's a huge exam trap, Jian. Field lines can never cross." If they did, it would mean the electric field has two different directions at the same point, which is impossible. They are also always perpendicular to the surface of a conductor. Remember that for the true or false section. To wrap it all up, Shizuka said, we talk about electric flux, phi. It's the number of field lines passing through an area. Gauss's law is the ultimate exam shortcut. It says the total flux through any closed surface is just the enclosed charge divided by epsilon_0. Phi equals joint vec E C D O T D vec A equals Fray CQ underscore ENCL epsilon_0. Tsuneo nodded. Exactly. If you have a sphere around a charge, don't use complex calculus. Just look at what's inside the butterfly net. If the net is empty, the net flux is 0. The glowing lines faded as the sun began to set. Nobita looked at his notes, feeling a strange spark of confidence. I think I get it now. Physics isn't just invisible magic, it's a field of influence. Doraemon smiled. That's the spirit, Nobita. You're ready for the midterm.